Hey everyone, welcome back to Boon Channel. In this series, we are building an open data stack on Kubernetes for ingestion, transformation, and serving. Last time, we focused on ingestion. We landed data in min.io and tracked tables with Lakekeeper. Today, we enable the transform layer. Before we get into details, let me introduce today's demo app. We built a small e-commerce site with Next.js and Payload CMS. You can browse products, add to cart, and check out. The tables from this app are the data we will work with. We will ingest this data with DLT and land it in Iceberg. Then we will use dbt to transform it into staging and marts tables that are ready for analysis. Finally, we will run ad hoc queries and build notebooks in Querybook via Trino. Now, before we dive deeper, let me show you the result we are aiming for. Here is Querybook, the UI for ad hoc queries and notebooks. I will run a monthly revenue query through Trino. It returns monthly orders, unique customers, total revenue, and average order value. You can see total revenue trending upward in the bar chart. We will come back and explain how this is built right after. Now that you've seen the result, here's the plan. First, we cover the tools we are using today. dbt handles transformations on Iceberg. dbt is part of the project code, not a Boon stack service. Trino is the SQL engine. Querybook is the UI for queries and notebooks. Then we add Trino and Querybook to the cluster and verify they are running. With the environment ready, we walk through the demo app, seed data, ingest it with DLT, transform it with dbt, and query it in Querybook via Trino. First, let us look at dbt. dbt turns select statements into tables and views. You write models in SQL with Jinja templates or in Python, and you keep them in Git so they fit naturally into code review and CI. It ships with simple tests for not null, unique, and relationships so you can protect key columns. It also generates HTML documentation with a lineage graph, which helps explain how models depend on each other. Teams often start with staging models to clean and type raw data, then build marts for dimensions and facts. dbt also supports incremental models, so regular runs only process new data. In our stack, dbt connects through Trino and materializes Iceberg tables that Lakekeeper tracks. Trino is a parallel and distributed query engine. A coordinator plans the work and worker nodes execute it in parallel. You use ANSI SQL. That means different tools can run the same queries with the same syntax. Trino connects to many systems at once, so you can join object storage tables with relational data in a single query. That is called query federation. It supports open table formats like Apache Iceberg, Delta Lake, and Apache Hudi, and is widely used as a lakehouse query engine. Querybook is an open-source data querying IDE with a notebook-style interface called DataDoc. DataDoc lets you organize rich text, queries, and charts into a single notebook and collaborate in real time with your teammates. It's great for documenting analyses, sharing context, and keeping results up to date together. The Smart Query Editor is schema-aware. It auto-completes table and column names, highlights syntax, and lets you hover or click a table to see its details. For quick insights, you can create visualizations right inside Querybook and add them to your DataDoc to tell the full story. Min.io and Lakekeeper were covered in the previous episode. Since that release, the Lakekeeper install now creates an OIDC client for service-to-service integration. If you already installed Lakekeeper before that change, run just Lakekeeper create OIDC API client to create it. You will see the OIDC client ID and client secret. Store them safely. Now let's add Trino and Querybook to our Kubernetes cluster. If you are using Boonstack, Trino installs with one command, just Trino install. It sets up Keycloak authentication for the web UI and password authentication for the admin user. It also configures connections to PostgreSQL and to Lakekeeper, the Iceberg REST catalog in our environment. Then it generates the Helm values and installs the Helm chart. If you install manually, follow the same steps as the automation, but you apply them yourself while showing Trino readme.md on screen and using Trino just file as a concrete reference for the exact steps. I will only cover the important points here. End-user authentication to Trino is separate from the service-to-service authentication required for Lakekeeper. Configure Keycloak so that when Trino requests a token with the Lakekeeper scope, the token includes the Lakekeeper audience. Also, enable user impersonation so applications can connect as admin but execute queries as the logged-in user, ensuring correct permissions and attribution. Finally, make sure Trino uses the correct external URLs. Configure the traffic middleware to inject the X-forwarded host header into incoming HTTP requests so Trino sees the real host. One more note before we move on. The MCP Trino setup we point to here lets AI tools call Trino directly, which can dramatically change how you build queries. We may walk through it in a future episode. Next, let's install Querybook. We hit a few issues using the upstream Querybook with Trino, so we maintain a fork. I'll open this fork on screen. Building a custom Docker image from this fork and pushing it to your registry is recommended. The commit log shows exactly what changed. Before you push, make sure Cloudflare Tunnel is set up for SSH, just like we covered in an earlier episode. In the Cloudflare public hostname settings, set the service type to SSH and the URL to localhost 22. Then confirm your local SSH config looks like this. Once SSH to the remote host works, set Docker host like this. Then run Docker build and Docker push for your custom Querybook image. After the image is in your registry, set Querybook custom image and Querybook custom image tag in .env local to use this image, and then install Querybook with the just recipe. When installation finishes, add your Keycloak user to the Querybook admin group with this command. If you install manually, review the readme.md and the just file recipes in the Querybook folder for the exact steps and configuration values. Open the Querybook URL in your browser. Log in with your Keycloak account and click Demo Setup. You will see a DataDoc named World Happiness Report that uses SQLite. Run it to see a results table and a chart. We will configure Trino for Querybook later in this episode. Now, let me introduce the demo app we will use today. We built it so we can pull data from a real application, transform it, and analyze it end-to-end in this episode. This app was generated from the Payload CMS ecommerce template. Payload CMS is a framework for building a CMS on top of Next.js, so it fits nicely with a modern JavaScript stack. First, we need a database. I will create a new Postgres database for this app named ecommerce with this command. Clone the repository and CD into the project directory. This project also uses Mees to manage tool versions. Run Mees trust, then Mees install to trust the config and install the required tools. Copy .env sample to .env and edit the values. We will cover data seeding shortly, but for large seeds, I recommend enabling Keep Alive like this, so long-running requests and connections stay stable. Install dependencies with pnpm. If you run telepresence connect, you can reach the Postgres host, Postgres cluster, rw.postgres from your local machine. That means you could start the app with pnpm dev on port 3000 locally. In this episode, we will instead run it inside Kubernetes with tilt. Run tilt up, and in another terminal run telepresence connect. The image builds and Helm deploys the app. Open podname.servicename:3000 in your browser to verify the app is running. Then go to the admin dashboard and create an admin user. Next, we will seed data. We will load realistic fake data into the app so our analysis looks real. First, create the environment file for the just recipes. Copy the example and edit the values. Set Pexel's API key. Pexels is a photo and video sharing service. We use it to attach product photos. You can paste the key directly, but here I will write a 1Password reference and resolve it with the 1Password CLI at runtime. To run the seed with a size preset, run this command. Medium is the preset name. Presets are small, medium, and large. In this episode, we will run the seed through the 1Password CLI like this. Seeding time depends on your machine. It can take about 30 minutes. We will skip the progress here. The seed is complete. Open the web app and select the Shop tab. You should see products loaded. Then open the admin dashboard. Confirm that products and orders are populated. Now let us load the app data into Iceberg with DLT. The DLT code for this demo lives in the data ingestion directory. We will start with the source definition. In sources, Payload CMS.py, we define Payload CMS source. It pulls data from the Payload CMS REST API. With DLT, you define this by passing a config dictionary to REST API source. The config declares resources like products, orders, and users, and sets pagination and authentication. Next, we will look at the destination definition. In destinations, Iceberg REST.py, we define Iceberg REST catalog. We introduced this in the last episode. In this version, we added OIDC authentication. We authenticate with a service account using the client credentials flow. This fixes the issue where the Lakekeeper API token expires too quickly. Finally, we will look at the pipeline definition. The pipeline is defined in payloadpipeline.py. Here, we connect the source and the destination, configure the pipeline, and execute it. This runs the load from the Payload CMS API into Iceberg through Lakekeeper. Now let us run the ingestion. First, get a web app token and store it safely. cd to the data ingestion directory, then copy .env local example to .env local and edit the values. Set OIDC client secret to the secret you saved earlier. In this demo, we write a 1Password reference and resolve it at runtime with the 1Password CLI. Set keycloak token URL to the keycloak token endpoint. Set Payload CMS URL to the Kubernetes internal hostname. Set Payload CMS token to the token you just retrieved. Before running, from the Boonstack directory, create the min.io bucket for the Iceberg warehouse. Then create the Lakekeeper warehouse named default and a namespace named ecommerce inside it. When you are ready, run DLT with just DLT run. In this demo, we will use OP run to resolve secrets with the 1Password CLI. The run is complete. Now let us verify the created tables with the Trino CLI. On macOS, you can install the CLI with Homebrew. Connect to Trino with this command. Now I will run show catalogs to list the available catalogs. You should see Iceberg, PostgreSQL, System, TPC-DS, and TPCH. We will use the Iceberg catalog for our tables. Next, I will show the schemas in the Iceberg catalog. You should see ecommerce. Now I will list the tables in the ecommerce schema. These are the raw tables loaded from the app. Let me preview a few products to confirm the ingest. The data is in Iceberg and queryable through Trino. Now, let us transform the raw data with dbt. The dbt code for this demo lives in the data transformation directory. Before we look at the models, let me show you the project configuration. Here is dbtproject.yaml. This file defines how dbt materializes our models. dbt uses a two-layer architecture here. The staging layer materializes as views. Views are lightweight, so they are perfect for cleaning and standardizing raw data. The marts layer materializes as tables. Tables are persistent and optimized for analytics queries. Both layers store data in Iceberg via Trino, so they are queryable by any tool that connects to Lakekeeper. Now let me show you the models folder structure on screen. Here is what we have. In the staging folder, we define sources in sources.yaml. This file declares the raw Iceberg tables that DLT loaded. Then we have 9 staging models. Each staging model cleans and standardizes one raw table. They rename columns to snakecase, convert data types, and apply simple transformations. In the marts folder, we build our star schema for analytics. We have 4 dimension tables: categories, customers, products, and date. We also have 3 fact tables: orders, order items, and transactions. There is one bridge table that connects products to categories in a many-to-many relationship. The schema.yaml file defines tests and documentation for these models. Now, let me walk you through a few key files to show how this works. Let me show you a staging model, stg products.sql. At the top, the config block sets materialization to view. In the select statement, we reference the raw products table using the source function. This function takes 2 arguments, the source name and the table name, both defined in sources.yaml. We rename columns to snakecase for consistency. We also add business logic. We store prices in cents in the raw table, so we create 2 columns. Price in cents keeps the original value, and price USD divides by 100 to convert to dollars. This makes downstream queries easier to read. Now we move to the marts layer. Let me show you factorders.sql. Notice 2 key differences from staging. First, we use the ref function instead of source. The ref function references another dbt model. Here, we reference stg orders. dbt uses ref to build the dependency graph, so it knows to run stg orders before fact orders. This is how dbt manages execution order automatically. Second, this model uses incremental materialization and is saved as a table, not a view. On the first run, dbt builds the full table. On subsequent runs, it only processes new or updated records. This is much faster for large datasets. This model also includes a calculated metric. The subquery counts order items for each order. This is a common pattern in fact tables. Finally, let me show you the tests and documentation in schema.yaml. This file defines tests and documentation for our models. For fact orders, we test that order ID is unique and not null. We also test that status only contains expected values: succeeded, pending, or failed. dbt provides 4 built-in tests: unique, not null, relationships, and accepted values. You can also write custom tests in SQL. When you run dbt test, dbt executes all these tests and reports failures. This ensures data quality at every step. When you run dbt docs generate, dbt creates interactive HTML documentation with a lineage graph showing how all models connect. Now let us run the transformation. We run just dbt op run. dbt builds all models in dependency order. First staging views, then marts tables. The run is complete. Let us verify the results in Trino. I will show schemas in the Iceberg catalog. Now we have 3 schemas. The ecommerce schema contains raw data from DLT. The ecommerce staging schema contains dbt views. The ecommerce marts schema contains dbt tables. Let me list tables in the ecommerce marts schema. All our dimension and fact tables are here. The transformation is complete. These tables are now ready for analysis in Querybook. Now let us connect Querybook to Trino so we can browse the Iceberg schemas and tables in the UI. Open Querybook in your browser. Open Settings, then Admin Tools, then Environment. Click the plus button and create an environment named Default. You can delete Demo environment if you want. Next, from the left menu, open Metastore and add a new Metastore. Name it Trino. Select SQL Alchemy Metastore Loader as the loader. For the connection string, use the external Trino URL with HTTPS. The Python Trino client requires HTTPS, so do not use a Kubernetes internal URL. You can get the admin password with this command. Enable the impersonate option. In Connect args, add a key named HTTP scheme with the value HTTPS, then click Create. Scroll to the Update Schedule section and create a schedule. Choose Hourly and create the task. We want to see results right away, so click Run Task to execute it now. Open Task Status from the left menu. Wait a moment and refresh until the status is Success. Next, add a query engine. From the left menu, open Query Engine and click the plus button. Name it Trino. Select the Metastore named Trino. For language, choose Trino. For executor, choose Trino. For the connection string, use the same external Trino URL used before, but do not include a username or password. Instead, input them in the fields below. Then click Create. Now, link the environment in the query engine. From the left menu, open Environment and select Default. In the Query Engine selector, choose Trino and click Add Query Engine. Trino is now available in the default environment. Click Back to Querybook at the bottom left to return to the main screen. You can see that Trino schemas have been loaded. Open ecommerce marts to view the list of tables. Open Fact Orders. Click View Table. Switch to the Row Samples tab and click Generate Samples to preview the data. The table appears in a grid so you can quickly scan the rows. Now, let us run a few queries together. From the left menu, open Ad Hoc to bring up the query editor. Type Show Catalogs and press Shift-Enter to run it. You will see the results appear in the area below. Next, list the tables in the ecommerce schema. Add a second statement under the first, and press Shift-Enter again. Because there are two statements, you will see two results. Use the selector above the results to choose which result to show. Now query the Fact Orders table. Select only the statement you want to run and click Run Selection. Only the selected statement runs and its results appear below. Next, let us create practical queries as DataDocs. For this e-commerce dataset, detailed examples are documented in the repo at docs.analysisqueries.md. We turn these into DataDocs in Querybook for the demo. Let me show you two interesting analyses. First, open the DataDoc named 5.3 Product Affinity Analysis. This query finds products that are frequently bought together. Let me walk through the SQL. The query uses a self-join technique. We join the fact order items table to itself on order ID. This finds pairs of products in the same order. The condition product ID is less than product ID ensures we only get each pair once, avoiding duplicates. We count how many times each pair appears together, then join with dim products to get the product names. Click the Run button to execute the query. You can see the results below. These are the product pairs most frequently purchased together. Next, open the DataDoc named 5.2 RFM Analysis. RFM stands for Recency, Frequency, Monetary. This analysis segments customers based on three dimensions: when they last ordered, how often they order, and how much they spend. The query is simple. We are just selecting columns from dim customers. The complex calculation is already done by dbt during transformation. Click Run to execute the query. The results show our top customers by lifetime value, along with their recency and frequency metrics. The customer segment column shows the RFM classification that dbt computed. You can see champions, loyal customers, and other segments. Marketing teams use this to identify high-value customers for retention campaigns and at-risk customers for re-engagement campaigns. Before we wrap up, let me mention a few more Querybook features that we won't demo today, but are worth knowing about. DataDocs supports rich text and markdown cells between queries. You can document your analysis, explain why you ran a query, what the results mean, or what action to take next. This makes your work reproducible and easier for others to understand. You can also share DataDocs with your team. Every DataDoc has a shareable URL. Your teammates can view the queries, run them again with updated data, and add their own comments. This makes Querybook a collaborative workspace for data exploration, not just a query tool. Today, we completed the transform layer of our open data stack. We started by installing Trino as our distributed SQL engine and connected it to Lakekeeper for Iceberg catalog access. We also installed Querybook as a collaborative query and notebook interface. Then we used dbt to build a star schema in Apache Iceberg with staging views and marts tables. dbt connects through Trino to materialize tables in Iceberg. We ran dbt tests to validate data quality at every step. Finally, we walked through a full e-commerce analytics pipeline, seeding a demo app, ingesting data with DLT, transforming it with dbt via Trino, and running advanced SQL queries in Querybook. Thank you for watching.